Welcome to This Explainer. I am so thrilled to have you here today. Look, if you've been reading the news, scrolling online, or just existing in the world lately, you have undoubtedly been bombarded by a whole alphabet soup of tech jargon. AI, ML, NLP, agents. I mean, it can honestly feel like everyone is speaking a completely different language. But today, our goal is simple. We are going to translate these complex tech buzzwords into relatable, everyday concepts. We're going to strip away all that intimidating jargon and use simple, metaphorical building blocks to understand exactly what is happening under the hood of modern technology. It all really starts with this one fundamental question. How do you actually teach a machine? We all know how human beings learn, right? We go to school, we read books, we practice, and, well, we complain about homework. But a machine? It's just metal, silicon, and electricity. How do you get it to actually know something? Well, as you're going to see today, the way we teach computers is surprisingly, and beautifully, similar to how human beings learn. Okay, let's dive into this lesson plan. First up, the man-made brain. Then, machine learning, the flashcards. Third, NLP, the human translator. Fourth, AI agents, the ultimate doers. And finally, putting it all together. Let's start with Section 1, the man-made brain and understanding artificial intelligence. When you hear artificial intelligence or AI, I want you to simply think of it as a man-made brain. That is literally the core of it. It's technology specifically designed to mimic human cognitive functions. It's this overarching concept of creating a machine that can think, reason, and process information in ways that resemble human intelligence. But of course, just calling it a brain doesn't really tell us how it actually gets smart. To understand that, we have to look at how this brain acquires its knowledge.
Which brings us to Section 2. Machine learning, or what I like to call the flashcards.
Machine learning, or ML, is a term that gets thrown around a lot, but its definition is quite elegant. It is simply teaching a computer to spot patterns without having to write a giant rulebook for it. Back in the old days of computing, if you wanted a machine to do something, a human programmer had to write out thousands of lines of explicit instructions. A massive rulebook, like, if X happens, do Y. But the real world is way too complex for giant rulebooks. We don't hand these modern machines a grammar textbook to make them smart. We use a completely different approach.
We use what we can think of as the flashcard method. Just think about how kids prepare for early school admissions. If you want a toddler to learn the alphabet, you don't sit them down, hand them a thick textbook on linguistics and say, "Learn to read." That would never work. They'd probably just try to eat the book. Instead, you show them a flashcard with the letter A on it, over and over again. And after seeing it enough times, their brain just automatically remembers the shape. They eventually just know it's an A without knowing any of the structural rules behind it.
And this brilliantly illustrates how machine learning operates day to day. It completely avoids that giant rulebook. Instead, it relies on showing the computer millions of digital flashcards. Let's look at a practical example, the spam filter in your email app. The creators of that app didn't sit down and write a million rules about what constitutes spam. Instead, they just showed the computer thousands or even millions of spam emails. They used those emails as flashcards until the computer learned to spot the malicious patterns completely on its own. It learned through exposure, exactly like a child learning the alphabet. Now, our man-made brain can learn by looking at digital flashcards, but all that learning isn't enough if we can't communicate with it.
So let's jump into Section 3, NLP, the human translator. NLP stands for Natural Language Processing. At its core, this is the technology dedicated to teaching the machine to read, write, and talk like us humans. Because here is the fundamental problem we face in technology. Humans and computers absolutely do not naturally speak the same language.
Computers inherently speak in cold, hard numbers and binary code. We, on the other hand, speak in words, slang, jokes, and incredibly messy, disorganized sentences. There's a massive communication gap there. NLP is the crucial bridge. It's the translator that takes our messy human language and converts it into something those machine numbers can actually process and understand.
Imagine for a moment a high school student sitting at their laptop, using a digital career guidance tool to try and map out their future life. Into the search box, the student types this exact phrase: "I want to work in tech, but I also love art." Now, to an old-school computer, that sentence is literally just a meaningless string of random alphabetical characters. But because of natural language processing, the tool doesn't just see random characters. NLP extracts the actual meaning behind that student's words. It understands the nuance, the inherent conflict of loving art but wanting to work in tech, even in a conversational, somewhat messy sentence. And by the way, this translator is the exact same piece of tech that powers the voice assistants you might have in your kitchen or your pocket. When you talk to Siri or Alexa, it's NLP that's doing the heavy lifting, translating your human voice into machine action. So we've gone from the brain to learning via flashcards to translating human speech. Now we are moving from passive learning to actual action.
Welcome to Section 4, AI Agents, the Ultimate Doers.
AI agents are systems capable of taking action on your behalf, and this is honestly the pinnacle of active AI right now. A standard artificial intelligence usually just sits there, passively, waiting for you to ask it a question before it spits out an answer. An AI agent goes a massive step further. It takes agency.
Now, what's really interesting about this is how we define that role. We call the AI agent the doer. Think of it less like a calculator or a search engine and a lot more like a highly capable personal assistant who actually runs errands for you while you sit back and focus on other things. Let's look at a really clear comparison to make this concrete. Say your internet goes down at home. If you ask a standard AI, how do I fix my internet? That AI acts like a smart encyclopedia. It'll instantly give you a link to a router instruction manual or a list of troubleshooting steps you can try. It gives you the information, for sure, but you still have to do all the work. On the flip side, if you engage an AI agent on your internet provider's customer service chat, it acts like a personal assistant. It doesn't just hand you a manual, it actively tries to fix the problem for you.
Let's see how this builds in real time. You tell the agent your internet is broken. Without you lifting a finger, the AI agent independently executes step 1. It runs a diagnostic test on your specific router. Finding an error, it moves to step 2. It remotely resets your connection. If that still doesn't work, it jumps to step 3. It automatically checks your calendar, looks at the company's dispatch schedule, and books a technician to visit your house. It ran the entire errand from start to finish. That is the true power of an AI agent. We've covered a lot of ground today, breaking down these complex concepts into action.
Bringing us to our final section, putting it all together and looking at your digital future.
So, the crucial point is how these three metaphorical building blocks actually combine to create the incredible modern AI ecosystem we interact with every single day. We start with machine learning, gaining knowledge through endless digital flashcards rather than rigid rulebooks. We add natural language processing, our translator, so this system can perfectly understand our messy, complex human requests. And finally, we package it all into AI agents, the ultimate doers, which use that learning and understanding to actually run errands and execute multi-step tasks on our behalf.
Which leaves us with something pretty fascinating to think about. We've traced the journey of these man-made brains, from simply reading digital flashcards, to translating our slang, to actively scheduling technicians to fix our Wi-Fi. The technology is shifting rapidly from passive answering to active doing. So I want to leave you with this question. As these systems become more capable every single day, what specific task in your life will you choose to hand over to the doers tomorrow? Thank you so much for joining me for this explainer. Keep learning, and I'll catch you next time.